Okay, so our first example is going to be in quadrant 1. And this says, given the coordinate 1, comma 5, find the sine theta, the cosine theta, and the tangent theta. So the first thing we're going to do is draw the diagram. Now when we draw it, we recognize that this is not a quadrantal angle. Okay, so what has to happen is we have to physically draw the path from the origin. So from the origin, we have to go X amount 1. So I'm going to go right 1. And then we're going to go up 5. So this amount is 1 and this amount is 5. We're then going to connect back to the origin. And this is where our right triangle is. Okay, so we're going to put our right angle in here. Again, the distance is X distance is 1. The Y distance is 5. And this is the radius of our circle. Now, this is not 1. So what we need to do is we need to use the circle formula, x squared plus y squared equals r squared, to find the radius and plug it in. So our x distance is 1, and our y distance is 5. And 1 squared is 1, and 5 squared is 25. And that makes r squared 26. And we need to square root to get the radius by itself. Right? Square root of 26 there and there. So what that does is it tells us that our radius is the square root of 26. So that's going to go over here in my diagram. All right. The last thing I really need is my theta. And theta is always anchored to the origin. So boom, there you go. So this lives in quadrant 1, because remember, quadrant 1 is from 0 degrees to 90 degrees, or from 0 pi to pi over 2. So this is quadrant 1. And if you notice, the x and the y coordinates are both positive. Now we are ready to take a look. You see, if I was going to do basic right triangle trig, I know that the sine of theta is opposite over hypotenuse. But look at how fast we can do this, because I know the opposite side is 5. I know the hypotenuse is square root of 26, and I know the adjacent side is 1 because it's between the angles. So instead of labeling all of this and doing, okay, opposite over hypotenuse and getting 5 over the square root of 26, I can just say instead, check this out, that the sine of theta is now y over r. My y coordinate is 5, and my r is the square root of 26. This goes a little faster. Now, neither of these are completely correct because we have to rationalize the denominator. So I don't care which one you do it to, but please do it. When you rationalize the denominator, you have to multiply top and bottom by that radical. So the sine of theta is going to be 5 square root of 26 all over 26. That is the sine of theta. For cosine, now that we know that this actually works, I'm just going to go a whole lot faster. Cosine theta is x over r. My x value is 1. And my r is the square root of 26. And all I have to do is rationalize. So I multiply radical 26 top and bottom. And I get 1 radical 26 over 26. This is my cosine. Drawing a nice line here. And then I've got my tangent function. So for tangent is y over x. My y is 5. My x is 1. That's just 5. And you're done. So this is what a quadrant 1 coordinate looks like. Stay tuned for quadrant 2.